and this is the beginning of the card response, in this case an ATQA. So we now move the stop cursor. Watch the USB min and max values here as you move it. So you have to move the stop cursor right to the beginning of the card response. So it's actually here. So what the tool now does is it calculates these USB upper sideband and LSB lower sideband maximum values in this area between start and stop cursor. And these are actually the EMD values as you need them. And you see here, okay, the values are below the limit for both of these. So in this case the test would pass. Let's play a bit around with that. If I move it, in this one here, you see the values increase by a factor of 100. That's because now it's not the EMD what is measured, but actually the load modulation amplitude of the card's response. But you want to avoid that, so you have to move the cursor a bit again to the left. So right in the beginning here of the signal, and you will see the values are much lower, and you see it here on the display, on the screen. You see some very small EMD peaks here, but they're outside the measurement range. Inside the measurement range you see basically nothing. It's just the ground floor noise here, and here of course what you see here is the load modulation amplitude of the card response. Assume you would have a card with very high EMD values, then you would see some peaks here on the signal flow level. And it would also then result in much higher values here and here. So, how to continue now? So this was the first measurement for the first command, in this case a request A, for a certain field strength. But, as mentioned before, you have to make many measurements with basically all commands in this test command sequence. So, you see here in this procedure, you have three options. The X option always means you can abort the procedure. C is continue with the next command, and R is repeat the previous command. In this case, the measurement went fine, everything was okay, so you do not have to repeat it, you can continue. But for example, sometimes the oscilloscope is not able to find the correct trigger point, and then you will not see such an image like this one here on oscilloscope, but something very different. In this case, you have to repeat the command in order to ensure that the measurement is correctly made. But now we want to continue, so I press the C button. So the next command would be anti-collision. You see here, the thing is, you have to ensure that the command can be reached. So typically you have to start again with request, and then you continue with the next one, anti-collision. So the trigger is only fired at the last command. So that's why it's called target command. So if you see that if you look at that on the oscilloscope, you will see an image which looks kind of similar to the previous one. So of course the reader signal is longer just because the anti-collision command, the 9320, is longer than the request. It's 2 bytes instead of 1. And you see again that the distance between the end of the reader transmission and the beginning of the card transmission is very short. So, but this image is correct. So you can now repeat the steps which you did previously. So you have to again use the EMD checker software. At first you have to check the TEPSCC value, which in this case is 10.75 microseconds. You enter this value here,